Hello students, in today's video we will talk about Snell's law of refraction. Refraction, you are already familiar with this term. When a ray of light is going from one medium to another medium, then it changes its path, and bending of light ray due to change in medium is known as refraction of light. And this glass lab activity also you have done already. This is outline of a glass slab, and in this glass slab this black line is representing incident ray. This is normal drawn at this point of incidence. This medium is air, this medium is glass. So when the ray of light will go from air to glass, air is a rarer medium, glass will be a denser medium, so it will bend towards the normal. This is incident ray. This is normal. After refraction, this ray will not go like this. It will bend towards the normal. So this is refracted ray. This side also black, this side also black. Angle between incident ray and normal. This is angle of incidence I. And angle between refracted ray and normal. This is angle of refraction R. So in Snell's law, we will see the connection between incident ray, normal, refracted ray, angle of incidence, angle of refraction, and all these things. So let us move towards first law of refraction given by Snell's. According to Snell's law of refraction, the incident ray, this ray, refracted ray, this one, and normal to the interface. This is normal. Interface. This is interface. Interface means the face that is separating the two medium. Two media. One is air, one is glass. For example, if this is glass slab, then ray of light will come and strike this face. This face. So this is representing interface. So incident ray, refracted ray, normal to the interface of two transparent media at the point of incidence, all lie in the same plane. This is incident ray, refracted ray, normal at the point of incidence. And where is this point of incidence? At the interface. It means the face that is separating the two media. All are going to lie in the same plane. This paper is a plane. Plane means a flat surface, two-dimensional, where if you will draw any 2 points like this and you want to join them with a line, then that line will lie on that flat surface only. So this paper is one plane. If I will consider this is x-axis, this is y-axis, then this is representing xy plane. So in this plane only our incident ray is present, refracted ray is present, and normal is present. So this is Snell's first law. The incident ray, refracted ray, normal to the interface of two transparent media at the point of incidence all lie in the same plane. It means if you will consider it on the floor, then all these three will lie on the floor. No ray, neither incident ray, refracted ray or normal will be on the wall of the room. If all are on the wall, then nothing will be on the floor, because wall is representing another plane and floor is representing another plane. Let us come to Snell's second law. The ratio of sine of angle of incidence to sine of angle of refraction. Ratio means like this. Sine of angle of incidence to sine of angle of refraction is a constant value, provided condition is the color of the light should remain same, and for a given pair of media, it means this medium and this medium should remain same. Let us consider this law once again. For a given pair of media, it means during experiment you are not going to change the medium. Air you will not replace by water. And glass also you will not replace by any other medium, oil or something else. So for a given pair of media, this value will come out to be constant. And also you should not change the color of the light. If you will change the color of the light, then this ratio for one light will be different, and for other colored light this ratio will come out to be different. And if during one reading you are going to have air glass and for other reading you are going to have water glass, then also this value will change. This will remain constant. This ratio will not change when the media or two medium that you have considered you will keep same for every reading. Also the color of the light will also remain the same. It means this constant can change with change in medium. Also this constant will change with change in color of light. This constant will not change if you are changing angle of incidence. See, for angle of incidence I, this is angle of refraction R. Now focus on green colored ray. Line this green color is representing incident ray. As angle of incidence will increase, for previous ray this was angle of incidence, for new ray this is angle of incidence. So when angle of incidence will increase, as pair of media is constant, color of light is also same. So to keep this factor constant, what will happen? If I is increasing, angle of refraction will also increase. So see, in this case, for I we are going to have R, and for I1 we are going to have R1. So sin I upon sin R will be equal to sin I1 upon sin R1, and this will be equal to a constant. And this constant is known as refractive index. And how we are going to represent this refractive index? This representation can be like this also, A mu G. In few books this can be represented by N also. So this is A mu G, or you can write it mu in subscript GA. A is representing air, the medium for incident ray. See, incident ray is going to lie in air. G is representing the medium for refracted ray. So how will you read this? A mu G, mu GA. These two terms you will read like refractive index of glass with respect to air. Where the bending of ray of light is taking place, that should be read first. And the medium through which the ray of light is coming, incident ray medium, that will be later on. So A mu G, how will you read? Refractive index of glass with respect to air. This will also be read as refractive index of glass with respect to air. The medium that is causing the bending or refraction will be written first in this case, and through which the ray of light is coming, that will be written later on. So this is Snell's law. Again, incident ray, refracted ray, normal at the point of incidence on interface, all will lie in the same plane, and ratio of sine of angle of incidence to sine of angle of refraction will remain a constant quantity, provided the color of the light should not change and the medium in which you are doing the experiment, those two medium should also remain the same. So watch this video carefully and do practice.